You are driving through town at 12 meters per second when suddenly a ball rolls out in front of you. You apply the brakes and begin decelerating at 3.5 meters per second square. How far do you travel before stopping? And then find the speed of your car when you have traveled half the distance in part A. Nice. All right, so again, we hopefully you recognize that this is one-dimensional kinematics, because again we're just moving in one direction, right? So the idea here is this. So let's say,
so we have speeding and then we stop, right?
Yeah, so for this one, basically this. So let's say this is the object. So object is moving initially, right? So you have, let's say, the car. So it has an initial velocity of 12 meters per second x hat. And then it says you apply the brakes and begin decelerating. So your acceleration then given as 3.5 meter per second square. But when it says decelerating, what does it mean?
Negative 3.5.
Exactly, negative. That means you are slowing down, right? This is just pretty much the indirect way of saying that you're definitely going to slow down, and you can only slow down if your acceleration is an opposite sign of your velocity. So if I take velocity to be to the right, acceleration then will be to the left as a vector, so it will be negative. All right, so so that's what we have, and it says that how far do we travel before stopping? So what does it mean as information? What information does it give us?
How fast you?
No, it says how far. We want to look at how far, but it says before stopping. So what does that mean? So we want to find how far, which means distance, but what happens at the end?
They're looking for final distance when velocity is 0.
Velocity is 0. How do we know that again?
Because it says
And the car stopped.
Exactly. That's a key, right? If you have to understand where it says travel before stopping, that means how far do you travel until you stop, basically. That means if I take this as my point A, and when I get to point B, the car will have no velocity. That means the final velocity will be 0. Okay. And I want to know, what is this displacement between points A and B? Okay. Again, that's very important information there. And we want to know, let's say, right, so let's write that down, given. So we are given that initial velocity is 12 meters per second. We're given acceleration as negative 3.5 meter per second square. And we're given that final velocity at this point is 0. Let's say this is for this part, right? Going from A to B, and B is the final position for me, and it's 0. So what I want to find here is displacement. What is displacement? Okay. Now, again, one-dimensional kinematic problem, because we can assume that this guy here is constant. So then we go and again look at equation. V final equals V initial plus AT. Equation 2, delta x equals V initial time plus 1/2 AT squared. Equation 3, V final square equals V initial square plus 2 times acceleration times delta x. Equation 4, delta x equals V initial plus V final, that divided by 2 times time. All right, so then how do I solve for the delta x? Which equation will give me delta x, taking into account what I'm given? I'm given initial velocity,
the third one.
acceleration, and final velocity. Sorry, somebody said third one, right? That is actually correct, exactly. That means what you want to do here, you want to have one equation that solves the problem directly. There are a couple of ways we can solve this problem. Actually, I can use, for example, equation 1, solve for the time, then plug it into equation 2 or 4 and solve for the displacement. But equation 3 directly gives me that, because remember, what I have here is I have initial, final velocities and acceleration, but I don't have the time. I don't know how long it takes until it stops. But equation 3 is time independent. It doesn't need time, and I can use that. It says equation 3 again, V final square equals v initial squared plus 2 times acceleration times delta x. See, I have everything because this is 0, right? I have then 0 equals initial velocity is 12 meter per second square, then plus 2 times acceleration, which is negative 3.5 meter per second square, then times delta x. As you can see, right, I have everything except delta x, and then we can go ahead and solve for that. So basically to do that, we rearrange, move this 2 times negative 3.5 times delta x to the left. So, rearrange sides. So 2 times 3 negative, or thing like this. So this, this 2 times negative 3.5 will give me negative 7. And then if I move it to the left, becomes 7 times delta x equals 12 meter per second squared. Then just divide both sides by 7. So that means 12 squared divided by 7 will give me right. I get 20.5, 20.6. Okay. So technically, then I can, in a way, write it as 21, keep it 2 sig figs, because 3.5 is 2 sig figs. So either way is okay. So you can say 20.6 or just round it to 2 sig figs, so 21 meters. There you go. That means using equation 3, we were able to just solve for the displacement in just one step. All right, so part A is done. So let's look at part B. It says, find the speed of your car when you have traveled half the distance in part A. That means what we're doing here, we kind of, I don't know, like reversing everything back. That means we're saying, okay, so let's say right now we know what MB, which is, let's say, 21 meters. And then we're going to say, all right, so let's go back and assume that, we start from A with the same speed, with the same acceleration, but instead of traveling 21 meters, we travel half of that, which is, I don't know, let's say 10.5, right? Let's say 10.5 meters. Let's call this point C, right? That means now we're going from A to C. Okay, so we don't need this anymore. And what I can do here is this. What I had for, remember, for the part A, I assumed that when we reach our final destination, the car stops. But is the same thing true right now for part B?
No.
It's not, exactly, because, we know that it's going to travel, double that distance until it stops. So what I have here is, I don't know, let's say what the speed is at point C, but it's definitely not 0. Okay. But I also don't have the time. But what I have right now, let me kind of rearrange this. I still have the same acceleration. I still have the same initial velocity. But now what I also have is the distance, right? I know between distance from A to C is 10.5 meters. That means now I have those 3 information, and I want to find what is the speed. Again, going back to equation 1, 2, 3, and 4, which one of them will give me the answer?
The third one again.
Excellent. Exactly. The third one again. Since, again, see, equation 1, 2, 4 need time. And I have absolutely no information about time. But I don't need to, because equation 3 takes care of that. Final speed square equals initial speed square plus 2 times acceleration times delta x. And I have everything. All I have to do is just square both sides. Square both sides. V final comes out from the left side. On the right side, I cannot take that out of square root because I'm 2 terms adding, but I don't need to. So it's 12 meters per second plus 2 times negative 3.5, then times 10.5 meters. There you go. So then plug in everything, calculate, and we should get V final. Let's see, 12 square plus 2 times, or minus technically, minus 3.5 times 10.5. But I did everything correctly. I got 8.4 meters per second. There you go. So that's welcome to do the calculation. All right, any questions? All right, so let's continue to the next one. All right, so Michael Jordan vertical leap is reported to be 42 inches. What is his kickoff speed? Give your answer in meter per second. All right, so now what type of problem is this? How would you categorize this problem?
Projectile.
Close, but not quite. We're talking about vertical. So this is the key, right? It's a vertical leap.
Free fall.
Free fall. Remember, projectile is also free fall, but it's a two-dimensional free fall. But if you go only vertical, you know, that's just one-dimensional free. That means straight up. So basically what we're saying, let's say here's Michael Jordan. He's going to jump straight up, and it can jump 48 inches above the ground, which is quite high. All right, so that means what I have here is relative to the ground, we know that it's going to go and reach, well, clearly not there, right? So basically, think like it jumps, and he's here. Usually he kind of goes like this, right? When he's jumping. So we're saying that this distance here is 48 inches. All right. So that means we're given displacement. We are told that delta y is 48 inches. Okay. Well, now remember, in order for someone to jump up, what do you need? What is the requirement for you to be able to jump up?
Starting velocity.
Exactly. You need some kind of starting initial velocity. And that's what we want, right? Takeoff speed or starting velocity. That means we want to know what is this starting velocity, you know, to allow you to jump 48 inches above the ground. So we're given delta y, and it seems like there's absolutely nothing else given to us. We're just told he can jump as high as 48 inches. But remember, this is a free fall. What other information do we have about free fall that I can write down as given?
Gravity.
Gravitational acceleration. Remember. So that means vertical acceleration is equals to negative g. Now, let's take the ground to be point A, and let's take the position it jumps 48 inches, point B. What other very useful information do I have about this? Going from A to B. Sorry,
We
go
have
ahead.
final y position.
Well, I have that. See, I can say
you have-
delta y is 48, but what other thing?
You have the
Final
when
velocity is
yeah.
zero.
Yes, somebody said final velocity, that means velocity at B, right, is 0. Why? Because it's the highest position, right? It's going to jump to 48 inches, stop, and come back down. And that's what I have, right? And what I want to find is V initial. What is V initial in vertical direction? Again, we have delta y, we have acceleration, we have final velocity 0, and I want to find initial velocity. So I'm hoping that, you know, it seems like we are stuck on this one specific equation, but hopefully you can see, right? Again, it's the same equation as we just used, right? Modified to negative 2g times delta y. It again has to be this equation because I can use this equation to solve it in one step. But, you know, what I can do, I can, you know, calculate the time and then use another equation. But right now, this equation 3, kinematics equation 3 for free fall, remember, the equation is like this, right? Plus 2ay delta y. I'm just saying ay is negative g. So I like to modify the free fall equations to in a vertical direction to indicate that that's what we're dealing with. All right, final velocity, that means it's velocity at B. Initial velocity is velocity at A. We know that final velocity is going to be 0. Initial velocity is what we're trying to find. It's a negative 2g delta y. Rearrange this. if I kind of rearrange this, then it's going to be VA squared equals 2G delta Y. And then all I have to do is just square both sides. So VA is equals to square root of 2G delta Y. So 2 times 9.8 times, well, before doing anything, we have to calculate 48 inches in meters. So 48 inches. And here we can say that, you know, if you want to convert, right? I don't remember exactly from inches to meters, but I remember from inches to centimeters, because 1 inch is 2.54 centimeters. But then I know that 100 centimeters is 1 meter. That's, I think, you know, one, you know, at least maybe you guys know directly from inches to meters. I just don't remember that. But I always remember 1 inch is 2.54 centimeters. So 48 times 2.54, then divided by 100. So I get 1.2, let's say 1.22 meters. When I go here, I say 1.22 meters. I remember this is meters per second square. So then my final velocity will be square root of 2 times 9.8 times 1.22 for displacement. That gives me 4.9 meters per second. All right, so that will be then the velocity of Michael Jordan in order to be able to jump 48 inches. This is, see, I imagine most of you probably don't really have a good, I don't know, visual understanding of what is 4.9 meters. Most of you probably know in terms of miles per hour or something like this. So think like this, anything that is meter per second can be considered as double what will be in terms of miles. That means 4.9 meter per second. So let's say it's roughly 5, right? If you double that, that represents sort of like miles per hour. That means it's about 10 miles an hour. That means you can jump with a speed of 10 miles an hour. Let's see, who had a question? Go ahead, Jessica.
So the 9.8 is not going to be negative.
No. See, first of all, this negative, I added both sides to G delta Y. That means I move this to the other side, right? But G itself, remember, G itself is always 9.8 meters per second. This negative was because of the direction, and I incorporate that right there. So you guys want to always be careful. See, vertical acceleration is equals to negative G, but G always 9.8. That's the magnitude. G is always 9.8. So well, you can say that vertical acceleration has the magnitude of G, but it's in a negative y hat direction. So that's why this negative, if I'm writing these equations as negative G, it already takes into account the direction. If you want, you can always leave this as plus AY, and then say that AY is equals to negative 9.8 meter per second squared. We can do that. But again, G is not 9.8. AY is negative G, where G is 9.8. So this is G, and this is the direction of, you know, where it's acting.
Thank you.
You're welcome. All right. Let's go to the next one. Again, remember, this is the time where you guys need to ask me questions. So if you have any question at any time, just raise your hand, let me know. Okay, so you shoot an arrow into the air. 2 seconds later, the arrow has gone straight upward to a height of 30 meters above its launch point. Well, again, hopefully you can recognize that this is a one-dimensional free-fall problem, right? Because you shoot an arrow into the air, and it's straight upward. So this is not a projectile. This is just a one-dimensional free-fall. All right. So basically, 2 seconds later, the arrow has gone straight upward to a height of 30 meters above its launch point. And what you want to find here is what was the arrow's initial speed, and how much time did it take for the arrow to reach a height of 15 meters above its launch point. All right, so I don't know, let's say here's the arrow. I'm going to just make it as a particle, and I'm going to say, okay, so it would be launched with some initial velocity in order to go straight up. Now, what I have here is I say that All right, so it goes up, 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 and for 2 seconds, and then let's say this is position A. And then what I know here is that when it reaches position B, which is 2 seconds later, vertical position of B is 30 meters relative to vertical position of A, which can be considered as 0. Okay. All right, now question is this. Does it stop when it reaches position B? Read the question and let me know. Does it stop when it reaches position B, which is 30 meters above the launch point?
No, it doesn't. stop there.
No.
No, right? Because it doesn't tell you that it reaches the highest position or it reaches maximum height or it stops at 30 meters per second. It just tells you that, as it travels up, 2 seconds later, it reaches 30 meters, but maybe, it continues moving. We don't know, and we don't care. We just given information that going from A to B, the time takes, right, from A to B as 2 seconds. And 2 seconds later, it reaches this position. But it's already, you can see, right, it's already enough for us to calculate the, the initial velocity. Okay, because again, what we're given delta y of 30 meters, acceleration of negative 9.8 meters per second square, and then time, right? Time is equals to 200 seconds. So go back to equations. V final equals V initial plus acceleration times time, vertical acceleration, we'll put it like this, right? Or delta y is equals to V initial time. I'll do it in terms of acceleration. Plus 1/2 vertical acceleration times time square. Equation 3, V final y square equals V initial y square plus 2 times vertical acceleration times delta y, and so on and so forth. So let's say at this point, what do you guys think? If I want to find what is V initial y, which equation can I use?
First equation.
First one.
First one. All right, can somebody help me clarifying why I can't use the first one?
You don't know the final velocity.
Exactly, I don't have the final velocity. I don't know how fast it is going here. I don't know what the velocity at B is. And then we agreed, right? It's not 0.
Yeah.
So I can use, let's say, a different equation right now to calculate initial velocity, but I cannot use equation 1 for sure because it has 2 unknowns. I don't know this one and I don't know that one. So I am kind of stuck with if it's just equation 1. So, but remember, I don't have final velocity, but I have displacement, I have time, and I have acceleration.
Equation 2.
Equation 2, exactly. Well, I can't believe I actually didn't finish this. Okay. So equation 2, exactly. You can say, right, because it doesn't care about final velocity, it doesn't need it. So what I have here is, let me kind of then get rid of the rest of the equation. So I have time, I have space a little bit. All right, so what I have here is then the displacement, delta y, equals V initial time plus 1/2 AYT squared. And I need to kind of rearrange where I'm solving for V initial. So remember, you can always switch the sides of your equations. That means I can rewrite this as V initial y time plus 1/2 AYT squared equals delta y. I can switch the, swap the sides. Remember, what I want here is this quantity. That means I want to isolate this. That means now I need to get rid of 1/2 AYT squared. That means I subtract both sides from that. This is from both sides, right? That means this is minus 1/2 AYT squared, which will cancel this one from here. That means if I do this operation on the left side, I will only have V initial times time plus initial times time And then what I need to do here, just then divide both sides by time, right? Then to have this initial velocity. Like that. Right, so just a little of algebraic manipulation, but you should be able to go around and calculate that. All right, so then let's do this. So this is then 30 meters. Then minus 1/2 times 9.8. Then 2 seconds squared. Then divided by 2 seconds. And we can just calculate this. All right, so let's do that. 30 minus 0.5 times 9.8 times 2. That's the top. I get 20.2 divided by 2. Well, I get 10.1 meters per second, assuming I did everything correct. That's what I got. That means it moves. It was shot at the speed of 10.1 meters per second, which is roughly 20 miles an hour. Doesn't seem correct to me, though. What am I missing?
I think it's because I wrote it differently. I wrote it applying gravity right away. So then it would be plus 1/2 times gravity times t squared.
Correct.
Because we moved it to the other side.
I just realized that I forgot that I'm using a y rather than negative g. So yes, correct. So sorry guys, this is let me see. This is negative, but then ay is negative then. Okay, yeah. I'm like, it can be 10.1. It's too slow for that, for it to reach 30 meters. Okay. That means there's a minus there by ay is also minus 9.8. And that's why. So this is minus to cancel the other minus, that you end up basically adding them. There you go. Thank you. So that means 30 plus 0.5 times 9.8 times 4. And this is divided by 2. So I get 24.8 meters per second. Okay.
25, yeah.
Well, I have 3 sig figs everywhere, so I'm keeping 3 sig figs. Yeah, so this looks a little bit more, All right. So that's basically part A. We're still doing part A here, right? So, but again, so what you have here is once you recognize what's given to you and recognize that part B is not your highest position, that means you don't know what final velocity is there. But you have a displacement, acceleration, and time. Equation 2 doesn't need final velocity at that position. Equation 2 then can solve it for you, can solve the initial velocity for you. Basically just rearrange it and solve for that. All right, let's look at part B. It says then, how much time did it take for the arrow to first reach a height of 15 meters above the launch point? Well, remember, our position B is 30 meters above. Well, that means position 15 meters above is somewhere between A and B. So maybe somewhere right here, right there. That's basically, let's call this position C. That means for part B, we are talking about object going from A to C. Okay. But here's the thing. I want to ask you guys. So why does it say how much time did it take for the arrow to first reach the height of 15 meters? Well, why does it tell you the first time? Does it reach the 15 meters multiple times?
It stays there for a moment before it goes down
Not
as acceleration changes.
no, acceleration, remember, is always fixed.
On its way back, it passes to the same point.
Exactly. Remember, if you throw something up, it's gonna go up, right? So let's say past some position C, but it's gonna go up, stop, and then come back down and go through this point C again, right, on its way down. That is why. That means, in a way, what I have here is I have, let's say, first time it goes through, from here to there, and it reaches point C. But then second time it's on its way down. That means it takes longer. It goes up, stops, come back down. So that's why it's a second time it goes. Generally, sometimes in the equation, you might end up with a quadratic equation, and quadratic equation can give you both times. So generally, quadratic equation can give you time for the first time and then the second time. All right, so, but for this one right now, we can easily calculate how much time it takes, because I already know that initial velocity is, oops, I erased that. I think it was 24.8, right? Meter per second. I know that acceleration is negative 9.8 meter per second square y hat. And now I know that basically displacement is 15 meters. So if I want to know the time, and then this is going to be the time, that means I directly need to just go from here to there. It means only about 15-meter distance. And I want to find the time. And the question is that which equation should I use to find for that? Remember, at this point, there's going to be a velocity here. So it's not stopping at that position. It's going to continue moving. All right, so I'm given initial velocity, time, initial velocity, displacement, acceleration. I don't know final velocity. So at this point,
The second equation.
exactly, second equation. Again, because I don't know final velocity, and any of the other three equations require final velocity. This is your best friend when your velocity final is not given. So delta y equals initial velocity times time. Then let me put like minus 1/2. This is for me the best way not to make mistakes. 1/2 gt squared. All right, so this is what I can kind of rearrange. So if I move everything to the left side, I end up with this 1/2 gt squared minus v initial times time, then plus delta y equals 0. Remember, g is 9.8, so half of that is 4.9 t squared, then minus initial velocity is 24.8 t, then displacement is 15, then I get 0. What does it look like, this equation that I have?
Quadratic.
Quadratic, exactly. I have 4.9 t squared minus 24.8 t. That means, I have basically a term with t squared, term with a t, and then a constant term. That means what you need to do, you just basically plug it into a quadratic equation and solve for time. And as I mentioned, right, it will give you two different types of times. And then you need to then understand that first one gives you the time to reach 15 meters on its way up. Second one will give you on its way down. Right, so who remembers the equation for quadratic equation? Let me do it in terms of x. X, or, I guess we can do it in terms of time. So time is equals to, what was the quadratic equation?
Negative b plus or minus the square root of b squared minus 4ac all over 2a.
Exactly. There you go. So remember, as far as I remember, I should have this on the formula sheet when I give you, but this is something definitely you want to, remember, because at this point, you can say, all right, so RA here is 4.9. RB here is negative 24.8, and C is 15. And then just take it and plug it into this equation. So it equals to, B is negative 24, and negative B, that means it's 24.8, plus minus, then you have the equation, quadratic equation, so it's a, so let's first do with a plus. And obviously you can always, I think some of the calculators have that ability, right? So 24.8 square minus 4 times 4.9 times 15. And this is divided, the whole thing, by 2 times 8, that means which is 9.8. Okay. $24.8 plus 24.8 square minus 4 times 4.9 times 15. So 42 divided by 9.8. All right, so I get 4.33 seconds. Okay. Can this be our time that we want? Can this be the time that we want? What do you guys think? Remember,
Time-
it takes
time
2
can't be
seconds
negative.
to reach 30 meters. So it cannot take 4.33 seconds to reach only 15 meters, right? That means this will be probably on its way down, reaching that. So that means what we want here, go back and use the negative one, right? And then just basically solve it from, with respect to that. All right, so if I look at the second time, so this is made basically my T2, my T1 is then 0.7 seconds, which makes more sense because, if it takes 2 seconds to reach 30 meters, it takes less than that to reach 15 meters. Remember, it's going to be slowing down after that. So that will be then first time.